Okay, so now we can return to where we left off here, and hopefully you have some understanding of why y equals k to the 1 half is what the book will use. So y equals f of k is just saying that y is a function of k. In other words, it is determined by or driven by k. Y equals k to the 1 half is a specific instance of that. It's specifying what type of relationship we're claiming here. And again, as discussed in the earlier video, any alpha between but not equal to 0 or 1 will fit our understanding of diminishing marginal returns. 1 over 3 would probably be a better estimate. That would be a cube root. But A, that would be confusing for many students, and B, it would be hard to do on a cheap dollar store calculator. So k to the 1 half fits fine. So let's look at this and see if this actually fits our underlying understanding. So I just put this into Excel. I put values down here, and so 90,000, the square root of 90,000 turns out to be 300. The square root of 10,000 is 100. And so now we can figure out, does this y equals k to the 1 half fit our understanding of diminishing marginal returns? So the book has this one here. They're showing that the first unit going from 0 to 1 causes output to go from 0 to 1. Whereas going from the 15th to the 16th unit creates a very small amount. And you could figure that out. 16, the square root of 16 is 4, and the square root of 15, let me look at that. I don't know that off the top of my head. Oh, I guess the square root of 15 must be 3.87. So the first unit of capital, as we've drawn this here, creates 1 unit of output, whereas the 16th unit of capital creates 0.13 units of output. So diminishing marginal returns. In other words, for each additional unit, we get an even smaller positive impact. So I'm going to do this slightly differently. My brain works a little bit differently. That's fine. That illustrates this. This, again, should be capital on the vertical. Nope. Capital on the horizontal, output on the vertical. So let's look at this. In order to get 1 unit of output, we have to change capital by 1. That's to get the first full unit change in output. How much do we have to change capital by to get the second unit of output? So we get a 1 for 1 for the first, and it turns out in order to get the second full unit of output, we're going to need to have 4 units of capital, which means our change in capital, in order to get 1 unit change in output, is going to be 3. So in order to get the first unit of output, it took 1. In order to get the second unit of output, it takes 3. In order to get the third unit of output, we have to increase capital by 6. If my memory serves. Nope, 5. Right? Because we have to go to 9. Yep. So that works out, not 10. So we have to go to 9. And so then we have to then we have 7, and then we have 9, and so on and so forth. In other words, we could look at it. The first unit of capital causes 1 unit of output. The 1,001st unit of capital causes 0.016 unit of output. Does this all fit with our understanding about the world of diminishing marginal returns? It absolutely does. And so that is why we have a capital equal, or an alpha equal to 1 half. Again, it could be anything, and we would get this same set of diminishing marginal returns. This, by the way, explains, you'll notice here, something to the east of China and the Koreas is Japan here. This time it is just Japan. It's not also South Korea. This actually explains why Japan grew so rapidly following World War II. In effect, what happened? We destroyed a lot of physical capital. We bombed. Japan had lots of bombs dropped on it. And their capital, bridges, factories, houses, all sorts of physical capital was destroyed. Which meant that if they kept adding capital at the same rate, if say that the United States and Japan added capital at the same rate. Now we haven't gotten to where changes in capital come from. We'll do that next here. But if we added capital at the same rate, the return in terms of output would have been higher in Japan. And as you may imagine, it was the same thing in the United States, but eventually maybe we ended up with some catching up. So this actually, our Solow model is useful in explaining some forms of catching up. One way to grow, by the way, if you want, this tells us, again, something that's more than a little bit perverse, but it tells us that if we want to grow economically, what we would need, one of the options, is to destroy a bunch of our existing machinery. We'd almost certainly grow more rapidly then, but we would also be worse off. So we would have higher growth rates, but lower levels of output. And that's really what we see here. Germany and Japan were destroyed and decimated by World War II. The United States was not. People in the United States suffered some minor travails during World War II, but really not. I mean, their kids went off and their siblings went off and their loved ones went off to fight wars, and you couldn't buy new cars and you couldn't maybe get fresh meat or butter, but it was nothing like what happened to Germany or Japan. And so Germany and Japan were dramatically worse off following World War II than they probably were before World War II, whereas the United States was not much better off, not much worse off in the big picture. However, Japan and Germany grew far more rapidly between 1950 and 1960 than the United States. Does that mean that Americans in 1955 should have traded places with people in Germany or Japan? I think if you went and talked to people in Germany and Japan between 1950 and 1960, they would have agreed, no. Nope, we don't. Americans should not trade places with us. Of course, by 1980, we pretty much, Germany and Japan and the United States have largely converged. Japan has a higher growth rate between 1980 and 1990 than the United States, but Germany has a lower one. So again, one way to grow is to destroy a bunch of your existing capital. Probably not a good idea, but analytically, this is helpful in explaining why Germany and Japan saw such rapid growth rates. This actually, by the way, does tell us that one of the things that may come out of the COVID response here is that we may see we may see a one-time period drop in GDP per capita, which, if it's protracted enough, would cause a recession. If, however, in that process, we destroy a bunch of physical capital, say we chop down all of the telephone poles in town in order to create ventilators. Clearly not going to be productive, but say we did that, and we tore up the roads and so forth. It would entirely be possible that we would see a dramatic decrease in GDP this year, and yet as we add more units of capital back to the mix going forward, that we actually would see higher growth rates than we otherwise would. We would still be worse off, but we would have higher growth rates. So hopefully one of the things you're going to walk away from this is an understanding that there is a trade-off sometimes between growth rates and growth level, or GDP growth rates and GDP level. Okay, so let's come back to this. And let's talk about capital growth. So we've charted out with this line what we expect the capital output relationship to be. Now, as I mentioned, it actually doesn't matter whether we use 1/2 or 1/3 at this point, or 2/3. As long as it's between 0 and 1, it will fit our understanding of diminishing marginal returns. But it turns out we haven't said anything at this point about whether capital will grow or shrink. We sort of implicitly, we have this understanding that we're going to start on the left with low levels of capital and work our way to the right. And that should make some sense when we look at the historical perspective. The default human condition is poverty. The default human condition is low levels of physical capital and low levels of growth. But we'd like to be a little bit more specific and also start talking about from where does capital growth come, either positive or negative. We're going to put two big categories in here. One is going to be investment. That is the acquisition of new capital. Now, you may notice that when we were talking about GDP, I alluded to the difference between consumption and investment. In our situation here, we're going to be assuming that all savings gets turned into investment. After the exam, we're going to relax that assumption and start trying to understand how and under what conditions does savings get turned into investment. So new capital, we're going to define investment here as the creation or acquisition of new capital. And depreciation is going to be the machines that break down and wear out. Now, some of you may be saying, oh, but wait, sometimes we repair machines before they wear out. And that is true. We would view the resources put towards repairing things as investment. Thus, we would still have a number of machines in which we invest and a certain number that depreciate. And our capital growth is going to be the number of machines that we add minus the number of machines that break down. Now, the book has this picture here. Investment, our investment line is the same shape as our output capital line, but it is lower down. So take a moment and see if you can think about and understand why would our, two questions. Why does our investment line have the same shape as our output capital relationship? And why is our investment line lower than our output capital relationship?